In this video, we're going to determine the derivatives of these combinations of the explicit function x, the unknown function f, and possibly an arbitrary constant c using our derivative rules. So remember, this notation here tells us to take the derivative of this expression with respect to x, and we'll do it piece by piece. So the derivative of x squared by the power rule is 2x, and the derivative of f of x will denote f prime of x, because again we don't know what f of x is right now, but we can still put its derivative in notation. Right here we have a product between x squared and our unknown function x. So this is going to be a product rule. So I'm going to hold the first part constant, x squared times the derivative of the second, which is f prime of x, plus, now I'm going to hold f of x constant times the derivative of x squared, which is 2x. Again, we don't know what f of x is, but if we did, we could plug it in its derivative and we'd have the derivative of this product. Part C, we're taking the derivative, we're going to do it piece by piece. Now the derivative of a constant c is just 0. The derivative of x is 1. And now here's an interesting one, because it's the first time we've encountered it. F of x, the whole quantity squared. This is like a composition with f of x being the inside function. So it's going to be a general power rule. So we're going to pull the 2 out front. We're going to leave f of x alone, and we're going to decrease the power by 1 times the derivative of the inside, which will be f prime of x. Now anything to the first power, we don't need to write the power, so we could write this as 1 plus 2 f of x, f prime of x. A couple more, just to get the hang of this. Now look at the difference in this one. This is f of x squared, but the square is inside the parentheses. It's inside the input. This will still be a chain rule, but different from here. Now the inside function is x squared, the outside function is f. So the derivative is going to be f prime, leave the inside alone. So that's the derivative of the outside, leave the inside alone, times the derivative of the inside, which is 2x. Right, so we're just applying our chain rule. It just looks a little different because we don't know what f is. It's not explicitly defined. All right, we got three pieces in here. We're going to do them each piece by piece. Notice the first will be a product rule. So let's separate each of these with parentheses. So let's just focus on this guy here. So the derivative of the first part is going to be, I'm going to leave the x alone, times the derivative of f, which is f prime of x, plus f of x times the derivative of x, which is 1. So that's the derivative of this first part. Now let's look at the second part. This will be a chain rule, and it's going to be very similar to D here, because we're doing f of more than just x. The outside function is f, this not explicitly defined function, and the inside function is cx. So the derivative of the outside function is f prime, leave the inside alone, times the derivative of cx, which is just c. The last one, we're going to do the derivative of c times f of x. That's just a constant times a function. So our constant multiplier rule, the constant's in our derivative, and the derivative of f is f prime of x. So what we've done is we've looked at taking derivatives when we have a function that's not explicitly defined. We've called it f of x. This is going to be our lead-in to doing implicit differentiation, because what we've done is we've implicitly defined that as a function of x.